Hello everyone. Today we are going to look at a numerical problem from the topic line reflection and refraction. So this particular question asks you to find out the object distance and the power of the lens. So we got the question on screen. So let's have a look at it. A convex lens forms a real and inverted image of a needle at a distance of 50 cm from it. Where is the needle placed in front of the convex lens? If the image is equal to the size of the object, also find the power of the lens. So the two things we have to find out is the position of the object, or we can call it the object distance, which is denoted normally by the letter U. Also, we have to find the power of the lens. So let's get down to answering it. So if you look closely at this question, you will see that the first part of the question is quite straightforward and much simpler, because for answering this you don't have to actually do any workout. So this part of the question can be approached in two different ways. Either you can use your knowledge, apply your brain and come up with the answer, or you can go with the more conventional route of using the magnification equation. So first, let's look at the much easier and simpler method of not using an equation. So this is what I call the shortcut. So if you look closely at the question, you will see that there are some pieces of information that are quite helpful. It tells you that obviously got to find the object distance, but then you get a real image 50 cm away from the object. So that means your image distance is 50 cm. So images in this question, the image is real. So you can see that real plus inverted, but we will only be looking at the real characteristic of the image in this case. So since the image is real, we are dealing with convex lenses. So in a convex lens, a real image will always be behind the mirror to the right side of the mirror. So the image distance V has got to be positive. So your image distance V is positive 50 cm. But at the same time, you also know that your object is real, and plus you know that the size of the object and the image are equal. So that gives us some clue to the magnification of the image. So when the size of the object and image are equal, we can take the magnification to be 1. So let's move on. So when you say the magnification is 1, or in other words, the object and image are of the equal size, that also means that the respective distance from the lens is equal. So if you say your object and image are of the same size, that also implies one thing. That means the distance of the object away from the lens and the distance of the image away from the lens are same. So since you know your V is 50 cm, your U also have got to be 50 cm. But one thing that you need to be careful about here is that since the object is always placed in front of the lens, your object distance U has got to be minus 50 cm, because everything to the left of the lens is minus and everything to the right of the lens is positive. We can arrive at the same answer, that object distance U is minus 50 cm using the magnification equation. But I don't think that would be necessary when we have got a much simpler and a straightforward method here. But however, for those who would like to know how the magnification equation works, I would like to show you how we can arrive at the same answer, that object is U minus 50 cm. So let's have a look at the magnification equation. So your magnification denoted by letter M equals the size of the image divided by the size of the object, or the distance of the image divided by the distance of the object. So that is equal to -1. So there is more to that -1, which I will explain later. So magnification, let us for the moment take it as -1. So the magnification -1 equals image distance, that is equal to 50 centimeter divided by the object distance. We are going to assume so far we don't know what the value for u is. So in the next step we will make u the subject. So u equals, u goes to the left hand side, -1 comes to the right hand side. That means u equals 50 over -1. That means u is nothing but -50 centimeter. Now, let me explain to you why we took magnification as -1. The first point I have already explained. The magnitude of magnification is 1. That is because the size of the object and the image are equal. Then there is another component to the magnification, that is negative. That is because your image is inverted, because you can find that piece of information from the question. So you can see it over here. It says in the question, you get a real and inverted image. That's what we are talking about. So when your image is inverted, the sign of the magnification invariably is going to be negative. So far we have answered the object distance. So we want it to be -50 centimeter, -50 centimeter in both ways, using the shortcut and using the magnification equation. So what you need to find next is, let's say, is the power. So if you look at the question here, you will understand it says also find the power of the lens. So now we are going to find out or calculate power. So in order to find power, first you have to find the focal length, because the focal length is always the inverse of power, or the power is the inverse of focal length. So for that you have to find the focal length using the length formula, which says 1 by f equals 1 over v minus 1 over u. So you know your 1 over v is 1 over 50, because v is 50 centimeter, minus, this minus comes from the equation, minus 1 over u. So u is, you know, that is minus 50, so you have to write minus 1 over 50. So following, you will get that 1 over 50 minus 1 over 50 is 1 over 50 plus 1 over 50, because these two minus together will become the plus sign. So that is nothing but 2 over 50. So your 1 over f is 2 over 50. That means your inverse of focal length is 2 over 50. That means your focal length will be, put it upside down, take the inverse. So focal length will be 50 over 2. So that will be 25 centimeter. Or in meter, it will be 0.25 meter. So we have found out the focal length. Next we can find out the power, because power P equals 1 over f, because power is the inverse of focal length. So that means P equals 1 divided by 0.25, and that is equal to 4. Because when 1 divided by 0.25 you get 4. Now you got to understand. So you got to understand that the unit of power is diopter. So your power is 4 diopter or 4D. So with that we have answered all part of our question. We have found out the object distance, which is equal to -50 centimeter, either using the magnification equation or using the shortcut method. And then at the end of the question, we also have found out the power of the lens 4D. And during that, even though it was not asked, we also had to find out the focal length, which is 0.25 meter. I hope you have understood this lesson. If anybody has got any question or would like any further clarification, feel free to drop in your comments. Thank you.